Welcome to All This Math. This is Professor Parker, and today we're going to talk about some geometry. All right. Now, I just want to say, geometry is not really difficult if you know all the rules and you know the theorems and you know the vocabulary. A lot of people don't do well in geometry because, for one, they don't know the vocabulary, they don't know the terms, they don't understand the definitions of the vocabulary, and they don't know the theories. All right. So what we're going to do today is go over some of the theories and some of the terms from one specific aspect of geometry, and in order that hopefully at least this aspect will become a little more simple to you. All right. So today we're going to talk about transversals, parallel lines, and different angle relationships that are created when a transversal, and I'm going to tell you what that is in a minute, when a transversal crosses two parallel lines. All right. So take a look at this diagram right here, right? From this diagram, we're going to figure out what the measure of angle 1 is. This is angle 1 right here. We're going to figure out the measure of angle 2. This is angle 2 right here. Angle 3, angle 4, angle 5, angle 6, and angle 7. We're going to figure out all of that. All right. Now, notice though, we're given this angle right here. We can call this angle 8. It don't really need its own number. It has a measurement, 69 degrees. All right. And from just knowing that piece of information, we can figure out the measurements of all of these other angles based on the fact that what we know about angle relationships that are created, right, when we have a transversal, right, that crosses two parallel lines. Now, a transversal, by definition, it's a line that crosses two or more parallel lines and creates angle relationships or creates angles from crossing or intersecting those parallel lines. Now, how do I know that these lines are parallel? That's another question. I know these lines are parallel because of these arrows that are drawn within the line, right? So you're always going to have arrowheads at the end of the segment that's drawn. That signifies that that's a line that goes on forever in both directions. But when you have the double arrowheads drawn on the line, that's how you know that they're parallel, right? Now, parallel lines will never intersect each other, and every point on one parallel line, the corresponding point on the other parallel line will always be, so the distance that those two are from each other, every pair of corresponding points will be the same distance from each other or equidistant, right? That's why those lines are parallel, and that's why they'll never intersect each other. All right. That's what makes them parallel. Okay. Now, let's talk about how we can start figuring out the measurements of these other missing angles, angles 1 through angle 5. So first, I know this is a 69-degree angle. So I look at this angle and I look at where it's positioned at. And I know that this angle is on this side of the transversal, right? The left side of the transversal, and it's in between the two parallel lines, right? So I want to look for another angle that has a similar relationship to that. So I look over here and I see angle 5. Now, let me tell you why angle 5 jumps out at me. Now, again, I'm approaching this from the perspective of a person that's been doing this for years, that already understands these rules. So that's how I'm breaking it down to you, right? I'm going to tell you that angle 5 jumps out to me because angle 5 is an alternate interior angle, just like this is. Now, this is what I mean when I say alternate interior angle. I'm going to write that up here. Alternate interior angle, right? This angle and this angle are on opposite sides or alternate sides of the transversal. This one is on the left side. This one is on the right side. That's the alternate part. They're both interior because they're in between the two parallel lines. So you got the alternate part, that's on the left side, that's on the right side. The interior part, angle number 5, and this angle right here are both in between the parallel lines. So once you identify two angles as alternate interior angles, you already know the relationship. Alternate interior angles are congruent. Alternate interior angles are congruent. Now, what does congruent mean? Congruent means that they have the same measurement. So once you identify two angles as alternate interior angles, then you already know what the measurements are because you know the measurements are the same. So if this one right here is 69, then angle 5 has to also be 69. So we just do this, 69 degrees. So we know one of our angles, right? Because we know they're alternate interior angles. Now, what else do I know about any of these other angles? I'm going to tell you, angle 6 jumps out at me. I'm going to tell you why angle 6 jumps out at me. Angle 6 jumps out at me because in relation to the angle that's 69 degrees, angle 6 is what you call a corresponding angle. A corresponding angle. So we got corresponding angle. And corresponding angles are congruent. Now let me tell you what corresponding angles mean. You have a corresponding angle if they're both on the same side of the transversal, right? Corresponding angles got to be on the same side. They got to either both be on the left side or both be on the right side. They got to either both be above the transversal or both be below the transversal. This 69-degree angle and this angle that's labeled angle 6 are both on the left side of the transversal. That's one part. That's only one part, though. The other part is that they both have to have the same relationship to the parallel line. So, for example, this 69 is below the parallel line. This angle 6 is below this parallel line. So they're both on the same side of the transversal, and they're both beneath the parallel line that helps create them, right? Because remember, these are angles. Angles are created by two rays that come together, right? So this parallel line and this parallel line are, they create angle 60, the 69-degree angle and angle 6. So they're corresponding because they're on the same side of the transversal. They're both on the left side. And just like this one is underneath of this parallel line, this one is underneath that parallel line. So that makes them corresponding angles. And that's why angle 6 jumped out at me, because I was like, okay, like I said, I've been doing this for a long time, right? I took geometry for the first time back in 9th grade. That was like back in 93. You know what I mean? That was like, yeah, back in 93. So, that's back in 93 when like the number 8 Jordans came out. That's been a minute. The originals, not even the retros, but the originals back in 93. That's a long time ago. So I've been looking at this and I kind of have an understanding. So I'm trying to translate that understanding onto you, right? So they're corresponding. Now, corresponding angles are congruent. So if I know that this is 69 degrees, I know that angle 6 has to be 69 degrees. Oh, you know what? I'm tripping. I forgot to label that. So angle 6, boom, angle 7, boom. Angle 6 is also 69 degrees. I forgot to draw the spaces for them. All right, so cool. So I know what angle 5 is. I know what angle 6 is. All right, what else jumps out at me? Let me see. All right, what about angle 2? Angle 2 jumps out at me too, also because these are called vertical angles. Vertical angles. And vertical angles are congruent. Now, what are vertical angles? Vertical angles are angles that are across from each other when two lines or two line segments basically form an X. So you see how this line crosses with this line? This transversal crosses with this line right here. They form an X, right? And the angles that are across from each other are called vertical angles. Not the angles that are adjacent or next to each other, but the angles that are across from each other, right? So the angle that's 69 degrees and the angle number 2, those are vertical angles. So that means they're congruent. So this is also 69 degrees. All right. Now, the angles, there are different ways, which you might have picked up on already. There are different ways to tell what the measurements of these missing angles are. Like, for example, if I already knew that angle 6 was 69 degrees, angle 6 and angle 5 are vertical angles. So you see how, and we already knew that angle 5 was 69 degrees also. But you see how like different rules in geometry can overlap themselves and they can like prove. So we have multiple ways of proving whether angles are equivalent or congruent or whatever. Right? So what else? Let me see. What about angle 4? Angle 4 jumps out at me. And I'm going to tell you what about angle 4, because angle 4 and this 69 degree angle have a special relationship. Those are called same side interior angles. Now, same side interior angles are supplementary. Same side interior angles are supplementary, right? So Why are they same side interior? Why do they call that? Because they're on the same side of the transversal. They're both on the left side. This angle and this angle are both on the left side, right? All right, both on the left side, and they're interior, right? That means they're in between. Interior means they're in between the two parallel lines. All right, so they are supplementary. Now let's make sure we know what supplementary means. Supplementary means you can add the angles together and their sum is 180 degrees. That's the definition of supplementary. Supplementary means you add the numbers together, you add the measurements together, and they add up to 180. 180. All right? So that means if I know that this angle is 69, and I know that this angle plus this angle must equal 180, the way I can figure out the measure of this angle is basically just do this. 180 minus 69. I do the mental math. 180 take away 60, that gives me 120. Then 120 take away the 9, that's going to give me 111. Boom, 111 degrees. So now I know angle 4 is 111 degrees. Now, if I know that angle 4 is 111 degrees, now angle 3 jumps out of me too, because I know the relationship between angle 4 and angle 3. Angle 4 and angle 3 are alternate interior angles. Alternate interior angles. Because look, angle 4 is on the left side of the transversal. Angle 3 is on the right side of the transversal. That's alternate sides. One's on the left side, one's on the right side. It's like a street. Imagine the transversal is a street. This angle is on the left side of the street. This angle is on the other side of the street. Right? You know how like in some cities you got alternate street parking, right? If you don't move your car in the morning, they're going to give you a ticket, right? Alternate side of the street parking, right? Left side of the street, right side of the street. So angle 4 and angle 3 are on alternate sides of the transversal, and they're interior because they're both in between the parallel lines. So that's why angle 4 and angle 3 are related like that. So if I know angle 4 is 111, I know angle 3 must be 111 because alternate interior angles are congruent. All right. Now I only got 2 more angles left to do. Right? Now I got angle 1 and I got angle 7. Okay. All right. Now what I can do is I can say, okay, well, angle 1 and angle 4, they got a relationship. So angle 1 and angle 4 got a special relationship. They are corresponding angles. Because look, angle 1 and angle 4 are both on the left side of the transversal. Remember, corresponding angles are on the same side of the transversal. That's one of their attributes, right? They're both on the same side of the transversal. But also, in relation to the parallel line, they have the same relationship in respect to that parallel line that they touch. So angle 1 is right above this parallel line, and angle 4 is right above this parallel line. So they're both on the left side, and they're both above their own parallel lines that they touch. So angle 1 is above this line, angle 4 is above this line. So that makes them corresponding. So if angle 1 corresponds to angle 4, that means that angle 1 and angle 4 are congruent. So then we got 111. Because if angle 4 is 111, angle 1 must be 111. All right. Now, one last angle, angle 7. Now, there's a couple ways I can figure out angle 7. One way is, dig what happens here. See how these lines cross? They form an X. So that means angle 4 and angle 7 are congruent because they are vertical angles. And vertical angles are congruent. So if I know what angle 4 is, I automatically know what angle 7 is. Angle 4, 111. Angle 7's got to be 111, right? Now, I'm going to write the answer, but I'm going to show you another way to tell what angle 7 is. I'm going to give you another one. There's something called alternate exterior angles, and they are congruent. Alternate exterior angles. Now, if you really understand what alternate interior angles are, you should probably be able to figure out what alternate exterior angles are, right? Dig this. So I know that angle 1 and angle 7 are alternate exterior angles. Now, what does that mean? The transversal is right here. Angle 1 is on the left side of it. Angle 7 is on the right side of it. So that's the alternate part. They're on alternate sides of the transversal, right? Now, how are they exterior? They're exterior because they're not in between the parallel lines. Essentially, they outside of the parallel lines, right? They're exterior to the parallel lines, right? They're on the outside. The angle 1 is up here outside of the parallel line. Angle 7 is down here outside of the parallel line. They're not in between. See, all these angles are in between. Angle 3, angle 5, angle 4, the 69-degree angle, those are all interior. right? If you thought of the space in between these two parallel lines as like a house, right? Where you could be inside the house or you could be outside the house, right? Above the parallel line is outside the house. Below the parallel line is also outside the house, right? So if you think about it like that, you kind of understand what's interior and what's exterior. Now, alternate exterior angles are congruent also. So if I already knew what angle 1 was, then I automatically know what angle 7 is, 111 degrees. All right. And now, like I said, that's just a little bit of geometry. A little bit of work with transversals, something like transversals, alternate interior angles, alternate exterior angles, vertical angles, corresponding angles, same side interior angles. Oh, let me point something else out too before we go. So same side interior angles, some textbooks are going to call those consecutive interior angles, right? Some textbooks are going to call those consecutive interior angles, right? That's just another, another name for them, like a nickname. You know what I'm saying? Just like we have nicknames, So hopefully you learned something new today. Please like the video. Please subscribe to the page. Please share the video. Put it out there to people, other people that might benefit from this information and gaining this type of understanding. And always remember, as usual, there's all this math all around you. Peace.